Hey class, and welcome to lesson 3 for space science. Just a reminder, if you have not done the previous 2 space lessons, you need to go back now and do those before you watch this lesson. Before we get going today, make sure you have some tabs open. You should have the questions that I'll post on the Google Classroom, and you can answer these questions while I go through the video. You can pause and answer the questions as I go through, or if you want to, you can answer them at the end. And once again, you can copy and paste them from my document by highlighting and selecting copy by pressing 2 fingers on your touchpad, or you can go Control C and copy, and then going into your new document, you can press Control V to paste, or you can press down again with 2 fingers and select paste, and they'll put them in your brand new document. All right, let's begin the slideshow. So last time we talked about scale and distance of the moon from the Earth, and now we're going to look at the sun, the only star in our solar system, but not the only star in our galaxy or the universe. So now let's think about how big and how far the sun is from the Earth. And we have this awesome picture of an astronaut at the International Space Station. So in this model, we're going to picture another everyday object, a soccer ball, standard size soccer ball. So the sun equals a soccer ball. A soccer ball is what we're going to use. In this case, if the sun is a soccer ball, I'm going to have you guess right now which model would best fit the Earth, A, B, or C. In Model A, we have marbles. One marble would equal the Earth compared to the soccer ball. In Model B, we have a peppercorn. This is what pepper looks like before it's ground down. Maybe some of you at home have a pepper grinder in the kitchen for fresh pepper. So one of those peppercorns would equal the Earth. Or C, a single grain of sand. So it's asking you, I'm going to have you guess which model, A, B, or C. Go ahead and press pause and add that to your document and go ahead and guess now. All right, are we ready to reveal the answer? Okay, in this case, the best model, if the sun represents, the soccer ball represents the sun, model B, the peppercorn. Earth would be as small as a peppercorn. A marble would be too big, and the sand would be too small, about the size of a peppercorn, which is pretty wild to think about. We look at this model here, shows the other planets in the solar system in comparison to this size of the sun. That picture is pretty grainy. Sorry about that. I'll try and make a better picture next time. Another example, we see the Earth and Moon, and that's just how tiny the Earth would be compared to the sun. It's huge. And the crazy thing is the sun's actually a pretty average sized star. There's stars smaller than the sun, and there's stars much, much bigger than the sun. But we on our little planet here, we're so tiny. In fact, if I go back there, I didn't even say it. My face was in the way. My bad. Just put my face on the sun there. 1.3 million Earths could fit in the sun. So I believe that's one of my questions there. How many Earths could fit in the sun? 1.3 million of our planets could fit in one sun. Next slide. Sunlight reaches the Earth in 8.3 minutes. That's going the speed of light. So every bit of light reaching us during the day took 8.3 minutes. You could just about round that up to 9 minutes, but so it's almost 8.5 minutes to reach us. It's pretty wild to think about. And speed of light is the fastest we even know about, fastest anything can travel. Now let's look at that number. The number of how far the sun is from the Earth is 93 million miles. That's such a huge number, it's hard to picture it, and that's why we use models, is to picture just how far things. And now if we're talking kilometers, it's 149.6 million kilometers. Remember, in science, we use metric and standard. So that's miles, and this is kilometers. That's a big number. So now I'm going to show you some ways that we can imagine that number better. Because when I just say like a big number, it sounds like a lot, but it's really hard to picture just how far it is. So we have to kind of think about it, like all those numbers in our head. No, well, how far is that? Like that's 93 million miles. What does that mean? Well, let's imagine something we travel in a lot, a car, your everyday car. When you're on the freeway or highway, um, the speed limit's about 60 miles per hour. So we're going to think about a car going 60 miles per hour. That's about how fast you go on the freeway. That's usually the safest you can go at a fast speed when you're traveling somewhere. If you're traveling on the freeway to like Seattle or something, if there's no traffic, you're going about 60 miles per hour. So imagine you're in a car traveling down the freeway pretty fast. That's about the fastest we usually go in a car in everyday life. So traveling at 60 miles per hour, it would take, oh my gosh, my thing's in the way there. It would take about 6 months to get to the moon. Now, the astronauts did it in 4 days, but that's because they were going way faster than we would be going 60 miles in a car. They were going 2,040 miles per hour. Much faster. And in fact, they were actually coasting the whole way. But I'll talk about that later. But right now, we're keeping in mind that car going 60 miles per hour. Now, let's say you want to drive to the sun in your car 60 miles per hour. Of course, you can't really do that, but let's just imagine that. If you want to go to the sun at 60 miles per hour, that would take you 177 years. That's longer than any human has ever lived. So don't think you're going to make it going 60 miles per hour to the sun. 177 years going 60 miles per hour. You would be pretty old if you made it, or not alive at all. That's just too long. That takes too long. So let's go to something a little bit faster. Let's think of a jetliner. If you've ever been in a plane before, an airliner, they go really fast. Takes us not a lot of time to travel long distance. If you want to go to California, it takes 2 to 3 hours. They go 550 miles per hour. That's much faster than 60 miles per hour. So even a jet flying at 550 miles per hour, it would still take 19 years. Still 19 years. You'd be alive when you made it to the sun, but 19 years, whew, I don't have time for that. I don't think anyone has time for that. Luckily, our spacecraft that we send places go much, much faster than that. But just to imagine, if you've ever been on a plane to go a certain distance, like, if I wanted to fly to Hawaii from here, it would take about 5 hours. If I wanted to fly to England, it would take about 10 hours. This would take 19 years to get to the sun. It's wild. So, one thing we need to take away with the sun, too, is remember that the sun is a star. All the stars you see are actually other suns. And they're just so far away from us. And we'll talk about that more on how they appear to us. It's the only star in our solar system. All planets, including us, orbit that star, orbit our sun. So it's the closest star to us, is the sun. It is the center of our solar system, and all planets orbit it. Now, that doesn't mean there's other stars when we look up. We're seeing them from a distance. And again, I'll talk about that later in more detail. All right. That concludes the slideshow portion for this lesson number 3. And now it's video time. I have 2 really awesome videos. These are some of my favorite videos where some very ingenuitive people make some models of the solar system to scale and just how challenging that is. One of them is Mark Robber. You've probably seen some videos from him before. And then there's this one where they go to the desert. You can watch them in any order. They're both models. I think the Mark Robber one's a little lengthy. I personally would start with this one. It's really cool. And that's Saturn right there, just to show you their scale. So go watch those videos. Enjoy. They're really cool. And have a good day, guys. And I'll see you tomorrow. Bye.